I'm Anil Kumar. Here is another interesting concept which we have picked from our book, Rediscover Algebra and Trigonometry. We have nested square roots, and the question here is find the larger number. So we have square root 2, square root 10, square root 5, or square root 5, square root 2, square root 10. So we have just changed the orders, and we need to figure out which one is larger. Now, there are a couple of approaches which you could do. One is that you can take all the numbers inside the innermost square root and then you can compare. Perfect. And the second is that keep squaring. Once you square, then the square roots will vanish and you'll be left with numbers which can be compared. Now, which approach will be better? Of course, the one which gives you lower numbers, correct? So, lower numbers will be by squaring or by taking the numbers inside. Well, when I asked this question to my students, most of the time they said, by squaring, you will get higher number. Is that so? Well, let's look into both the approaches. By that, we'll also understand what happens when we take a number inside a square root. So let's go with your suggestion, which is not to square, but to get into the root, right? So let's compare these two numbers. So if I have to write square root 2, square root 10, square root 5, uh, so I could also write this as square root of. So I'm taking 2 inside this, right? So when you take 2 inside a square root, it should have been 2 square, which is 4, right? So it will become, so I got rid of 1 square root. So when you take this, it becomes 4, right? Times 10. And here we have square root of 5. Okay, clear. For the other set, it will be square root of, so 5 I'm taking inside, so it becomes square of 5, which is 25, right? Times 2 and square root of 10. Correct. Let's repeat this process. So clearly we have 4 times 10, we are taking square root inside with 5. So nothing here. And so it becomes square of this, which is 16 times 100, right? So let me write 1600 times 5, right? Times 5, I'll write like this. So that's what you get within the square root. And for the other number, it will be what? 25 square will be there. So 625. So let me write 625 times 2 square will be 4 times 10. So, so that is going to be the number. Now you can see which one is greater, which one is smaller, and definitely you will know which one is larger. Perfect. But these are very big numbers to work with, right? Correct. Now, the alternate approach which I was telling you was to square them, right? So if I keep squaring, right? So keep squaring. Now, if you keep squaring, in that case, what happens to the first number? The square root vanishes, so you get 2, and then other things in the square remains like this. You get 10 square root 5, correct? In the other case, when you do the squaring, so 5 comes out of the square root and rest remains as such, correct? Okay. So that becomes the first step. Again, if you square, you get 2 square, which is 4, right? But then you get this 10 outside this bracket and square root 5. In this case, 5 becomes 25 when you square, times 2 and square root of 10. Now, when you square this time, 4 square is 16. Okay, so 16 times 10 square is 100. Okay, and then times 5. Great. Here, once again, we have 25. So we'll write 25 square and 2 square, right? And times 10. So almost the same numbers, correct? So either way, you actually land up with the same numbers. Now, the idea is to figure out which one is bigger. Well, to check this out, what we can do is instead of multiplying, we could actually simplify, right? Now, for example, 25 times 4 is 100, right? So we could cancel 25 and 4, so we get 100 cancelled off, right? And now we have 16 times 5 here. 5 can go with this with 5 remaining, correct? So we have 16 here to compare with 5 times 10, which is 50, and definitely 50 is greater. So we know that the second number is much greater than the first one. Of course, you could have done a similar calculation here also, canceling out 10, for example, right? So 1 0 vanishes. Just simplifying like this and dividing by 5 and dividing by 4, you could have simplified and got your result. But the idea here is to share with you that if you have nested square roots, you could follow either of these two approaches. Squaring, I find, is simpler for students to do because when we are taking the number within the radical sign, you need to square it. Sometimes students forget about it, so that may be a problem. But I hope that makes sense. So, uh, here in this particular case, we figure out that the number 5, square root 5, square root 10, square root 2, that was bigger, right? So it was kind of like this. I hope you find this approach interesting and useful. Thank you, and all the best.